Dear students, welcome to the next topic of thermodynamics, that is adiabatic process. We have seen isothermal process in which we have found that the temperature remains constant throughout the entire process, and therefore the name isothermal process. But here it's different, quite opposite to isothermal process. It's called adiabatic process. In an adiabatic process, the working substance, that is a gas, is perfectly insulated from the surroundings. It can neither give nor take heat from the surroundings. So therefore, when we assume that when work is done on the working substance, remember, the work is done on the working substance. Now how this can be realized? Suppose if you have here the piston, we already said this is the piston, and if this piston is brought down, you can see the arrow mark that is pushing it down. So if the piston is brought down, the working substance, that is the gas, is getting compressed, right? As a result, the pressure will increase and the volume is bound to decrease. And you will find, because the pressure increases and the entire system of the cylinder is completely insulated, due to the rise in pressure, the temperature is bound to increase, and the pressure increases the temperature also. So therefore we can even say the temperature, say for example from one level it will move to another level, say for example T1 to T2. And this is all about the adiabatic process. Let me repeat it. The work is done on the working substance by allowing the piston to move downwards such that the gas, the working substance, is getting compressed. As a result, the pressure increases. You can see the PV curve also. The point A, unlike in isothermal, it has come down now because we are going to move from point A. So when you press the piston down, from the point A we're moving up, therefore the pressure increases and then the volume decreases. And temperature has also moved from T1 to T2, which is, of course, T2 is the higher temperature. So therefore, in the adiabatic process, we understand that the system is completely insulated from the surroundings and there is always a change in temperature. So any thermodynamical process that practically that we know of, we have come across, that involves sudden change in temperature is all considered to be adiabatic. For example, explosion of a tire, explosion of a balloon, where there is a sudden thermodynamical state change, having a complete temperature change, right? So these are all the examples of the adiabatic processes. So the example is also given in the notes. It's also combustion of fuel followed by its expansion are all considered adiabatic in nature. And we follow an equation. An equation is followed here. PV power gamma is equal to constant, where gamma is the ratio of the specific capacity of the gas at constant pressure to the specific capacity of the gas at constant volume, right? So this is what we need to understand in the adiabatic process, where there is always a change in the temperature.